Okay, so last class we have seen about iterative model, incremental model. So in iterative model, as I told you, there will be small iterations. So each iteration will have all the software design steps. Okay, from starting from gathering the information until your implementation. So we will have for each iteration all the complete steps for software development. And also we have seen yesterday what is incremental model. They are almost similar in incremental model as I told you yesterday. So this we are going to develop in this we are going to develop the software based on increments. Okay, so each step will be considered as one increment. As you can see here in the diagram, so all those requirements gathering, analysis, design, coding, testing, implementation, this will be done in first increment. And similarly, in the second increment, the result will be stored here. Then again, we will have requirements gathering, design, coding, testing, then implementation. So this will become increment 2. Okay. So the concept between the iteration and incremental models, they are similar. So these two, if we combine, so that will make us agile model. So agile means it's nothing but versatile. The meaning of agile, it means versatile. So in agile process, there will be continuous iterations of development and testing. Okay. Here also we will have continuous iterations and iterations of development and testing. So here, as you can see in the diagram, each iteration we have all those requirement analysis, design phase, implementation, testing phase, everything. Okay. Similarly, in iteration 2 also we have, and iteration 3 also we have. So like this, until we get our optimal solution or optimal product, the iteration can go on up to n iterations, n number of iterations. Okay. So, and for every method, for every model, you can have different diagrams. Okay, but the concept will be similar. So you can find many other diagrams in internet about agile or for prototyping or for incremental or iteration model. You will find different diagrams. The way how they represent is different, but the concept inside it will be similar for all the models. So you can refer any diagram for your exam. Okay. So it is not compulsory to follow the same diagram I have shown here. So this is for your demonstration purpose, for your understanding. So you can refer this diagram, but you can also refer other diagrams for this process models. Okay. In waterfall model, there are more than 10 diagrams in waterfall model. Similarly, in your spiral and in your V-shape model, you have many other diagrams also. Okay. So, but for your understanding, the concept will be same for every process models. So that is agile. In agile model, we will have a continuous iterations of development and testing. And each iteration, they will be designed to be small so that we can easily manage the module. Okay. So agile, we have here some requirements. They are assumed to change. That means you can change your requirements in every iterations, and the system will have a series of short iterations. Okay, short iterations, you have to remember this term, short iterations. And also the customer, they can be involved in every iterations. Okay. Then finally the documentation part will be done if all these steps are completed. So like this, every iteration we can have your requirement changing, and also customers can be involved during its iterations. Now, and there is one advantage for agile model. It is they are very suitable for changing requirements. Okay, so suppose if a customer wants to produce or to develop a software, and meantime he wants to add some features in the software to be developed. So for adding the softwares, the features to be developed, then he has to add some requirements or he has to add some features, right? So in the next, once iteration is completed, so in the next iteration he can add the requirements. Okay, he can add the requirements or he can add or update the requirements. So this is the advantage of agile model, where in the running process we can add or update your requirements. Now, so agile model, as I told you, you can have different diagrams. There is also another example I'm just showing to make you understand that models can have different diagrams, but the concept will be same. So here also you can check here, there will be your planning of how to develop the software, then requirements analysis will be there, then that means your gathering of information, design phase is there, building means your construction or implementation phase, and testing phase. Okay, so this is considered as iteration 1, and the same thing, once if you do this, then you can update or change your requirements, and you can perform your second iteration like this. Okay, so each iteration will take a short duration, maybe 1 month, 2 months, or maximum to 3 months. So there will be, here it is written 2 to 3 months. Okay, so iteration 1, iteration 2, iteration 3, until iteration n we can have. So until we find the optimal product. That means what the user wants. Okay, this is another diagram and this is another diagram. The concept is same. So these are some methodologies or techniques of agile. In agile model, we have some other methodologies. For example, Scrum, Extreme Programming, Kanban, Lean, FBD, and like this. We have some methodologies how we are going to implement agile method. Okay, so that you can go through, and also I'm going to send one particular note for agile methodology alone. Okay, so here you can see Scrum. It consists of iterations because, as I told you, agile it is iteration and combination of iteration and incremental. So Scrum, it contains iteration which is called as sprints. Okay, so in Scrum, if we use agile and if we apply Scrum methodology, the iterations will be called as sprints. So each sprint will take 2 to 4 weeks time for completing one sprint. That means for completing one iteration, it will take 2 to 4 weeks long. Okay. Then after that, we cannot make any changes once the iteration is completed for one iteration. Okay. But if you want to make changes, then you have to go for the next iteration. So like this, we have another methodology called extreme programming. And Kanban is also one of the method which focuses on visualizations, and iterations will be made very short. And in extreme also, it will the iteration maximum iteration may take up to 2 weeks. Okay, the period may take up to 2 weeks to complete one iteration. So like this, you can go through. There are some other methodologies rather than these three methodologies in Agile, and the corresponding notes or materials also I will send. So in Agile, what you have to remember, the important thing is it is a combination of iterations and incremental model. There will be iterations also, there will be implementations also. Okay. So next one, we have prototyping model. So prototyping model, here we are going to construct different prototypes. Okay, this is also use the concept of iterations. So here you can see the diagram. First, you have requirement gathering, information gathering is done here, and there will be a quick design of the requirements gathering we have done, the quick design. Okay, so next step is to build the prototype. So the prototype means what? Some set of a kind of model, set of rules, right? Prototype normally means a set of rules. So here in prototype means one method or one model we are going to construct. Quickly, we are going to construct one model. Okay. Achilles Chauhan is joining just now. Roll number 5 has left the meeting. 5 and 25. 1 second. Okay, 25. Okay, so now, as I told you, we have prototyping model. Prototype means in general, what is the meaning of prototype? Some set of rules which we are going to follow. So in prototyping model, we are going to construct a prototype or construct a model. Then we will have refining, we will be performing refining prototype. Okay, there is a process called refining prototype based on customers feedback, based on customers feedback, and after that we will update the design here. Okay, and see here it is, we have an iteration here. Okay, first requirement gathering will be done, then we will do a quick design of the software model, then we will build the prototype. Okay, so here once we finish building the prototype, we are going to allow the customers to review this. So once the customer finish the evaluation, reviewing the model, the customer will give some feedback. So based on the feedback, we can refine the prototype by updating the design. Okay, so there is a loop here, there is an iteration here which we can do unless and until we find the desired or optimal product. Okay, once you find the optimal product, we can stop the process. This is known as prototyping model. Okay, so here there is a loop, here you have an iteration here. So this iteration is done in order to get a refined prototype which will give you the optimal product. This is prototyping model. Prototyping model, again we have some 4 types. The first one is rapid throwaway prototypes. Second one is evolutionary prototype, incremental prototype, and extreme prototype. So rapid throwaway. So from the name itself, you can understand something. Rapid means very fast, right? So quickly you are going to develop one model, and quickly you are going to develop the prototype. Then you are going to throw it away after reviewing by the customer. Okay, so that is what it is written here. Rapid throwaway prototype is developed quickly to show how the requirement will look visually. Okay, so quickly, we are going to design the prototype. Then the customer will review it, and after that, what we are going to do is, after reviewing, we are going to, if there is any feedback from the customer, we are going to update the requirements. Once we update the requirements, the prototype we developed will be discarded. Okay, the prototype we developed will be discarded. Okay, so this is the concept, rapid throwaway prototype. Once again, I'm explaining you. Quickly, you are going to design or develop the prototype, then it will be allowed to be reviewed by the customer. Once the customer finish giving the reviews, then we can update the requirements or we can change the requirements. And once we finished updating the requirements, then the prototype we developed will be discarded. Okay, that is rapid throwaway prototypes. Now, evolutionary prototype, so it is explained here. Even you can also go through. I have already sent the materials for this. So here the prototype we have developed will be incremented. Okay, why we are going to increment the prototype? Because we are going to get a refined prototype at the final stage. Okay, we are going to get a refined prototype at the final stage. So incrementally, we are going to develop the prototype. Like in incremental model, what we do in first increment, we develop the model, then the result will be stored in the next requirements. Then the second increment we develop another model, like that until we get an optimal product. We incremented the model and we develop the project. So likewise, here also evolutionary prototyping follows the incremental method until we get the final product. So this model is helpful for projects which use new technology, but that is not well understood. So if you want to apply a new technology and if you don't understand it properly, you can just apply evolutionary prototyping. Okay. This is because the requirements we are going to use are not stable. That is why we can keep on increasing, updating, or changing the requirements. So incremental prototyping, here small prototypes will be developed initially. Then eventually we will merge all the small prototypes into a single product. Okay, so this method also we use in prototyping model. So you can see here final product is decimated into different small prototypes and developed individually. Okay, so separately we are going to develop the prototypes, then finally the prototypes will be merged into a single product. That is incremental prototyping. And lastly, extreme prototyping. Here it is mostly used for web development. Okay, because here you can simulate data process by using the prototype service layer. So extreme prototype, the first prototype, it may be present in your HTML format. So these are the four techniques or four prototyping models: rapid throwaway prototypes, evolutionary prototype, incremental prototype, and extreme prototype. Okay, so the detailed notes I have already sent. You can just go through for your reference. And lastly, rapid application development, RAD model. So this RAD model, it is based on prototyping. So in prototyping, what do we do? In prototyping, what do we do? In prototyping, what do we do?
No.
Yes, tell me.
In prototyping, we make a small, quick model,
Yes,
which might not really be as complete as the final model, and then we update it based on customer feedback.
yes. So that principle we use here in RAD model. Okay, so in RAD model, you can see here in the diagram itself, prototype 1, prototype 2, prototype 3. Okay, so prototype 1, that means here we use the concept of prototyping model where we quickly design a prototype. Okay, where we quickly design here, you can see you do requirement information gathering, quickly design, then building the prototype. So this part, up to this part becomes one prototype before giving to the this customer evaluation and refining prototype. So here we have develop prototype 1. So prototype 2, how we are going to develop? By giving to the customer evaluation, defining the prototype. Again, if you update the requirements and if you do a quick design here, the loop goes on. So this concept we are applying here. And these are the steps to develop the prototype 1. So you have business modeling, data modeling, process modeling, application generation, testing and turnover. So we perform these steps to build prototype 1. Similarly, the same steps we follow to build prototype 2. Again, the same steps to build prototype 3 and goes on. Okay. Finally, this will be converted into your application code. So this is the explanation here. Business modeling, what we are going to do in business modeling, or what are the activities performed in business modeling. So in business modeling, it is just like getting the information, requirements gathering, okay, and distribution between various business channels. The product is designed. Okay, so requirements gathering or information sharing is done in business modeling. And in data modeling, we are going to collect some information from this business modeling, and then we are going to define into a set of data objects. Okay, so business modeling means what? We are going to gather the information and we are going to share the information between various business channels, and then we will convert this information into set of data objects in data modeling. Now in process modeling, so this data objects again transform into information flow so that we can implement your development of software. And next, in application generation, we use some automated tools. Okay, this will construct the software and also it can convert process and data models into prototypes. Okay, and finally, we have testing and turnover, where we are going to test the individual prototypes in every iterations. Okay, so every iterations we will perform our testing so that it will minimize the overall testing period. Okay, so these are the activities or the steps we have in rapid application development. Okay, so by this, this is the end of your process models. So we have seen waterfall model, we have seen V-shaped model, we have seen spiral, iterative, prototyping, and RAD. Incremental model also we have seen. Evolutionary model, it is nothing but all iterative types model comes under evolutionary model. For example, spiral model is also one kind of iteration, right? So this comes under evolutionary model. Iterative model itself, it comes under your evolutionary model, like that. All iterative types model comes under evolutionary model. An agile model, we have iterative model and incremental model, combination of these two. And we have seen all the diagrams, explanation, verification, validation, spiral model explanation, okay, iterative model, incremental model, agile, okay, so prototyping and RAD, rapid application development model. Okay, so the first up to process models, maybe not this week because it will be somewhat difficult for me to set the questions by tomorrow. So let me do your first quiz or first test on next week. It's better to do next week, Monday. Okay. So you have lots of time. Today is Tuesday only. So next week, Monday, that is on 23rd, we will have a test on, a quiz on process models and the introduction part. Okay. Now we will see your next topic. Next topic is UML. This will be your lab exercise part also. That means in your lab, we are going to do this UML. UML is nothing but Unified Modeling Language. Okay, so let me share the, one second. Okay, so can you see the screen? Can you see the screen? Unified Modeling Language. So
Yes, ma'am.
Okay. So this is your next topic. So before this, we need to study some software requirements and all. Those are all theory parts. So in next class, I will explain all those theory parts, software requirements, what are the software requirements, what is software requirement specifications, how to construct that one, what are design basics and all. We have some theory parts before UML that I will explain you in your next class. But for today, let us study UML, Unified Modeling Language. So this Unified UML, this is your lab section. In your lab, you are going to do UML. Okay. So that we can easily start your lab by next week. I'm just starting this topic. So UML. So UML, it stands for Unified Modeling Language, and this is the pictorial representation of your software blueprints. Just like your software blueprints, it is the pictorial representation. Okay, so this is used for specifying, visualizing, constructing, and documenting the artifacts of software system. So this we will see directly see the example so that you can understand what is UML. These are some concepts. What is a class? What is an object? What is abstraction? Encapsulation, inheritance, polymorphism. These are, I think you have studied in your OOPS, right? There is a paper called OOP, no? Object Oriented Programming. Have you studied the subject?
Yes, ma'am.
Yeah. There you have all these concepts. What is an object? Object is an entity. Class is what? Is an instance of object or the blueprint of an object. Abstraction, behavior of real world entity. Encapsulation means you are binding, you are going to encap the data together and hiding them from the outside world. Inheritance means you are going to inherit some property from the existing one. And polymorphism means you have different forms. Poly means many, okay, or different forms. So for this also, for UML, today I will send you the notes so that you can refer the notes and study the background of UML. So let us start UML diagrams. So here in UML, we are going to draw only the diagrams, okay. So the diagrams, once we draw the diagram, we can easily understand the thing, what is actually going to happen, or the overall architecture. So what do we do, like for example, if you want to write a C programming for addition of two numbers. So in that we will write an algorithm, and after that we will draw the flow chart, right? So that flow chart will make you understand the complete procedure of addition of two numbers. So how will you draw the flow chart for addition of two numbers? So we will have a start symbol, and after that we will have some rectangular type symbol where we can take the input. Then we will have some another rectangular symbol for addition of showing the addition of two numbers. Then for printing the result, like that we draw the flow chart step by step, so that seeing the flow chart we understand the concept of addition of two numbers, right? So similarly in UML diagrams also we have many diagrams, different types of diagrams, so that we can understand the whole process of software development. So we have normally four diagrams. First one is called class diagram. Second one is called use case diagram. And in third one, we have behavioral diagram. Behavioral diagram, we have again three types: interaction diagram, state chart diagram, and activity diagram. And in interaction diagram, we have another two sub diagrams, which are sequence diagram and collaboration diagram. And lastly, number 4, we have implementation diagram, which we have another two types under implementation. First one is component diagram, and second one is deployment diagram. Okay. So all together, I have written here, we are going to draw 8 UML diagrams. Okay. So these are like just to show you, under behavioral we have such types, under implementation we have such types. Just to show you, I'm giving this. Normally we are going to draw these 8 diagrams: class diagram, use case, sequence, collaboration, state chart, activity, component, and deployment diagram. Okay. Now let us see some notations before we draw the class diagram. So class diagram, we have three sections in class diagram. Okay, we have three sections in class diagram. We have class name is the first section or the topmost section. We have attributes as the second topmost, and we have operations as the third section. Okay, class name. So we are going to give some class name and attributes. So what are the attributes? So what can you tell me what is an attribute? Can you tell me what is an attribute? Okay, let me give you an example and you have to answer me. Okay, so I'm giving you the class name as student. Okay, the class name is student. Then what are the attributes of the class student? Can you tell me any attributes of the class
It could
student?
be name, roll number,
Yes, very
contact
good.
number,
Yes, yes. So the attributes of the class student are the features. What are the features? For example, student name is one feature, So that becomes an attribute. Then next we can have student ID or roll number. Okay. Then students department, that you can write as one attributes. So these are called attributes. And what are operations? Operations are methods or functions. So suppose you consider the same example, student name, a student as your class. Then what are the functions or operations for class student?
That could be a strength of class.
Not the strength, that is that comes under attributes, not operations. Operations are like which we are going to perform as an action. For example, your class student, this one, math, delete student, then add student, modify student, student names. You can write modify student name, class, modify your delete student name, add student name, calculate your CPI or calculate your marks daily, like this. So the actions which we are really going to perform on your class, that is known as operations. Okay, so I'll show you the example. So some notations are here. So interface notation is shown using this circle. We have interface notation, and name can be given student application, like this. Then example you see here. Where is it? Where is it? Yeah. Okay, example. And this is association. Association means you have to link with the classes. Link, there will be a link or association or relationship between the classes. The bank account is considered as one class, person is considered as one class. So there is a link between the bank account class and the person class. So this link is known as association. Okay. Interface we have seen. Generalization. So this is generalization. Vehicle, what kind of vehicles? Bus is a vehicle, truck is a vehicle, car is a vehicle. Okay, so like this is generalization example. And yes, now this part. So class diagram, the detailed class diagram for student class name, it is given here. Okay, so for this notations, you can go through notes today. I will send you the notes. You can go through the notations. So top section is used to name the class. So that is what class name. So I have named my class as student. Okay, student is the name of the class. Now the second section is to show the attributes. Attributes, I told you, they are called the features. So for student class, we have student name. Student name is a string. Student roll number, that is an integer. Student section is a string, like this. This is the attributes. So you can include student address, student phone number, many attributes are there. So I have just included here 3 attributes for student. Now, next section is your third section, that is operations. Operations section. So in operations, we have display student, add student, edit student, delete student. So they are also known as functions or methods. Okay. So these are example. And this is an additional component. You can have this section, or it's not necessary to put this section also. But you can have, or you can put this, but it's not mandatory. Okay, the fourth section is this one. Responsibilities. You can have managing the student in the class, during the class and all. So you can put this as an additional component, and also you can exclude this, and you can have only this three as your class diagram. The important part is top section, which is the name of the class. Second section is the attributes, and third section is the operations. Okay. So likewise, if I give you any class name, can you say the attributes, and can you say the operations? For example, I'm giving you ATM. ATM, everybody goes to ATM to withdraw the money, right? So you consider ATM is the name of the class. I have ATM class. Now tell me the attributes of ATM and the attributes of, sorry, and the operations of ATM. You can refer this example and you can tell me the answer. You can refer the class diagram, example for student, and now you consider ATM as your class. Tell me the attributes of ATM and tell me the operations of ATM.
Ma'am, name of account holder, ATM pin.
No, not account holder. That becomes the customer. If you say the account holder, then your class name will be your customer. Okay. Or the
Ma'am,
user.
pin, ATM pin.
ATM, oh, sorry, you consider that as your ATM machine. ATM machine. ATM machine. Consider your class as your ATM machine.
In that case, ma'am, maybe the card number will be the attribute here.
Card number.
Yes, ma'am. The expiry date.
Card number, if you say that becomes your, if you have your ATM card as your class name, then what you have said is correct. Your card number or ATM pin or account holder name, that can be your attributes. That is correct. But I'm telling you, ATM machine, the machine which you usually withdraw the money, that machine you consider as your class. If you consider ATM machine as your class, yes, tell me, Lakshmi Narayan, tell
Ma'am,
me.
cash left in the ATM to draw, ma'am. Cash left.
Cash,
Cash left in the ATM, ma'am. How many notes left in the ATM?
Ma'am,
And
bank
password.
branch and location.
yes, yes. ATM location can be your attributes, right? So just
Yes,
like
ma'am.
attributes means the features for describing the class. Okay, so if I say ATM machine is your class name, then you can have your ATM location as your attributes, ATM location, and that particular ATM machine might have some identification number, right? Suppose if it is there in NIT campus, there will be some ATM number, an ATM ID, just like your enrollment number. Okay, if it is located in NIT or somewhere, every ATM machine will have some ID number. Okay, that ID number can also be one of the attributes. And ATM location or ATM address, that is also one of the attributes. Okay. Then what are the operations of ATM machine?
Balance
Withdraw,
checking and withdraw amount.
balance,
Yes, yes, that all comes under operations or methods of ATM machine. Withdrawing money, checking balance, showing the balance, displaying the balance, and all. You can, whatever the operations you can see and you can perform in your ATM machines, that will become your functions or methods or operations of ATM machine. Okay. So why I'm telling about ATM, because this ATM machine will be your first exercise in your lab for drawing the UML diagram. So if I ask you to draw a class diagram of ATM machine, then you can draw the class diagrams, right? Can you draw the class diagram? If I ask you to draw for ATM,
Yes, ma'am.
Yes.
okay. Now we will just move on to one example and we will conclude today's class. So this is your example for ATM. Okay. But here we have two classes. First is ATM machine. This is the right side which you have is your ATM machine, and left side client. This is nothing but your customer or the user who comes to the ATM to withdraw their money. Okay. So this is your second class and this is your first class. So ATM one class, client or the customer is the another class. Now ATM ID, every ATM machine, as I told you, will have some ID, and also you can put some extra attributes, that is ATM location. Okay, ATM ID, ATM location. These are the attributes of
Can we
ATM.
put user authenticated?
Huh?
Can we put here user authenticated?
User
Authentication.
user authentication, that comes under your this one, no, operation. Authentication
Ma'am,
means you
I
are
read
doing
somewhere it can be put in Boolean attribute.
user authentication process comes under your operations, where you have to check the pin, you have to check your pin number if you enter correctly or not, like that. That comes on authentication process comes under operation. That will be explained here in the slide, you can see here. Okay. So that are some attributes. Now coming to operations part. Okay, reading the card. Once the customer comes to the ATM machine and insert the card, the ATM machine that will read the card. Okay, ATM machine inside they have some technology, some the chip and all for reading the card, right? So reading the card, that is one operation. Then checking the pin. So from the server, it will connect to the server. Once you insert your card, then every details will be read by the ATM machine, and it will check the connect to the server with your card's bank account, bank name, and it will check the pin, it will check the validity, it will check the amount, and all this giving the money and all, will dispense the money. Instead of giving the money, you can write dispense money. So all these things can be done from the ATM machine. And left side you see here, there is customer is the class name. So the attributes of customer are customer name, your ATM card number, ATM pin number. So all this can come under your attributes of the customer. And the operations of customer are what are the activities, what are the actions we can do, what are the actions we can do Inserting the card, he can do. Inserting the pin, he can do. Entering the amount he want to withdraw, he can do. Then collecting the money, he can do. Right. So these are some few operations which I have included here. You can include more, you can add more. Here also you can add more for the ATM. Okay. Now this is one class. This is one class. These are the properties of class. These are the properties of class. Now, in class diagram, a class diagram is drawn in such a way. Here we have shown an association here, link here, N1. What do you understand by N1? Can anybody tell me what do you understand this N1?
There can be a number of customers associated with one ATM.
Yes, very good. So there can be n number of customers that can come to one ATM and do his actions. Okay, so that this is called mapping. N to 1 mapping or many to one mapping. So this has to be included while you draw this. So this complete structure is known as class diagram. Okay, the complete diagram you show here, this is known as class diagram. So likewise, you can draw class diagram for hospital management. Can you draw hospital management? There
Yeah.
you consider hospital as one class and the patient as another class. Okay, you can include two or more classes also. But the concept here should have the same this kind of thing, no? Attributes will be there, operations will be there. So you can put patient as one class, doctor as one class, and hospital as one class. Okay. And you can put only two and do before you start using three classes. You can just throw with two classes also. Okay, for hospital management, you just consider patient party, or you can write patient as one class, and you can write hospital as one class, and draw a class diagram for hospital management. And next class when you come, you have to show the class diagram to me. Okay. You can write your own attributes, you can write your own operations. Okay. And you have to show me in our next class. This is for class diagram. And the second use case diagram we will see in the next class. Okay. Okay, so let me take your attendance and we will wind up for today. So roll number 1,
Present, ma'am.
Abhishek Anand present, right?